When diesel is burned, it releases carbon dioxide, which is one of the largest contributors to the greenhouse gas effect, causing an increase in global temperatures, elevated sea levels, and ocean acidification. The U.S. has about 9.1 million diesel-powered trucks in operation, using over 22 billion gallons of diesel per year. To put that in perspective, that amount could fill up the Empire State Building 79 times. Burning this diesel releases approximately 250 million tons of CO2 into the atmosphere. The majority of diesel fuel is currently produced through the refinement of crude oil. Instead of crude oil extraction, one alternative for producing diesel fuel comes from algae farming. Currently, algae is farmed through open raceway ponds, in which algae is grown in 1 foot of water that is constantly circulated through the algae, so the algae remains in suspension. These ponds range from 1 to several acres in size. Small-scale algae farming is done using a photobioreactor. Photobioreactors are closed systems, which pump water and algae through transparent tubes so that the algae can be exposed to light and grow. As of right now, photobioreactors are far too expensive to be used on large scales, but can be used in less than ideal conditions because they take up less space and have a controlled internal climate. The most popular method to extract oil from algae is a combination of a mechanical press and a hexane solvent extraction. Similar to the concept of an olive press, an oil press is used to extract up to 75% of the oil in the algae through mechanical means. After the algae has been through the oil press, a hexane solvent is added to the algae pulp. Any oil still present in the pulp will dissolve in the hexane. The pulp is then filtered out, leaving just the oil and hexane. Then the oil is extracted from the hexane. Together, these methods can extract to 95% of the oil from the algae. Once the oil has been extracted from the algae, it needs to be converted into a usable biodiesel. To do this conversion, a process called transesterification is used. In this process, an alcohol such as ethanol is used alongside a catalyst such as sodium hydroxide. The reaction converts the oil into a biodiesel with a byproduct of glycerol. The biodiesel is finally separated from the glycerol and is ready for use. One of the major benefits of the algal biofuel production process is its carbon neutrality. Algae biodiesel is considered carbon neutral because all the CO2 emitted by the fuel is consumed by the algae growth in the next season. Algae also generates in hours and days rather than months or years, so this provides more of a reliable diesel supply when compared to alternative biostock. For the same amount of land, algae produces nearly 10 times more biodiesel than soybeans, the leading biodiesel feedstock. In addition, algae demand would not detract from the national food crop supply as opposed to other biofuel sources. Algae-based biofuel does have its disadvantages. It costs about $7.50 a gallon, which is higher than the U.S. national average of $2.40 a gallon. Algae has specific growing conditions depending on the temperature, pH, and sunlight. To completely fulfill the U.S.'s demand for oil, 30 million acres of land dedicated to algae farming would be needed. This is slightly larger than the state of Pennsylvania. Current diesel engines cannot run off of 100% biodiesel due to the viscosity issues at low temperatures. The current safe standard for vehicles is a mix of 80% petroleum diesel and 20% biodiesel. In conclusion, the best way to meet the triple bottom line is by using a combination of biodiesel and petroleum diesel. This will reduce the annual carbon emissions and help cut the impact of global warming while maintaining economical prices at the pump.